Hello again, gang. Mr. Cruze here, once again working through a quiz review, this one for sections 8.3 through 8.5. Remember, your quiz is tomorrow, Friday, January 25th, 2013. It'll be a 15-question quiz, coincidentally the same number of questions on this review. Alright, in this video I'm going to do the first half of the review. So, number 1 says to simplify, state any restrictions on the variable. For the most part, you're going to see that a lot. State any restrictions on the variable, Anytime it says that, make sure you do. So we have 4x squared over 5y times 7y over 12x to the fourth. I'm going to go ahead and just multiply straight across. 7 times 4 is 28. X squared times y is just x squared y. Over 5 times 12 is 60. X to the fourth y. Right now you can already tell me x can't be 0, because if I were to plug that in, it would make the entire denominator 0, and we can't have that. Same thing with the y. Y can't be 0 as well. Now I can go ahead and feel free to cancel. 28 over 60. Well, 28 and 60 are both divisible by 4. 4 goes into 28 7 times, and it goes into 60 15 times. So, that's that. X squared over x to the fourth. The x squared goes away. The x to the fourth is going to become x squared. And then the y's, of course, cancel as well. So, on top, we are left with 7 over 15x squared, as long as x and y are not 0. Number 2, same way, only this is a division problem, so I know I'm going to have to do the KFC method. Makes you think of chicken. The keep, flip, change. Anytime you see divide, think KFC. Keep, flip, change. Keep the first fraction. So it's still 4x squared minus 2x over x squared plus 5x plus 4. Flip the second fraction. So now it's x squared plus 2x plus 1 over 2x. And change it to a multiplication problem. Now we just need to factor and then figure out what cancels. So what comes out of 4x squared and a negative 2x? That's 2x. And you're left with 2x minus 1 over what multiplies to 4 and adds to 5? Well, that's x plus 4 and x plus 1 times what multiplies to 1 and adds to 2? That's x plus 1 times x plus 1 over a 2x. Now, what can x not be? From here, it can't be negative 4. Can't be negative 1. It can't be 0. And technically, since this was in the denominator to begin with, I also have to check the numerator of this fraction, because we flipped it. But it ends up being negative 1, which we already have, so I don't have to repeat it. Now, what cancels? The 2x's go away. 2x and 2x cancel. The x plus 1 of them cancels out. Nothing else does, though. So, what am I left with? I'm left with a 2x minus 1, an x plus 1, those are both in the numerator, over x plus 4. As long as x is not negative 4, negative 1, or 0. And I'm okay with you leaving your answer like this. If you FOIL that back together, that's one more chance to make a small mistake. Same thing for 3, although I notice this is times, so I don't need to do any flipping. I just need to factor. What goes into 3x and negative 6? Well, that's a 3. And you're left with x minus 2 over, that's an x cubed, I'm scared. Don't be. Pull out an x, and you're left with x squared plus x minus 6, we'll come back to that, times negative 4x over, well, I guess we'll just factor this all at one turn here. So, what multiplies to negative 6 and adds to 1? Think about it. That would be 3 and negative 2. Times a negative 4x over what multiplies to negative 14 and adds to 5? That would be a 7 and a negative 2. So, once again, what can x not be? Might as well start a list. Can't be 0. Can't be negative 3. It can't be 2. It can't be negative 7. And it also can't be 2. Now notice, I do not have to check this numerator because it was never in the denominator. So those are my restrictions on x. And just see what cancels. Well, the x minus 2 cancels. And I've had questions about this all day. Does this x in the numerator and this x in the denominator cancel? You betcha. They go away. Don't let that negative 4 fool you. That's negative 4 times x, right? You can still cancel that. So we're only left with 3 times negative 4 in the numerator, which is negative 12, over the 3 binomials we're left with in the denominator. As long as x is not those. So there you are. Number 4 is division. Once again, so we're flipping. So I see division, I think KFC. Keep, flip, change. So we're going to have x squared minus 4 over x squared minus 2x minus 8. Change it to multiplication and flip the second fraction. Alright. Now factor. X squared minus 4 now becomes x minus 2 and x plus 2 over what multiplies to negative 8 and adds to negative 2? Well, that'd be negative 4 and a positive 2 times what multiplies to negative 12 and adds to negative 1? That'd be negative 4 and positive 3 over multiplies to 6 and adds to negative 5. That's negative 2 and negative 3. Now, what can x not be? Can't be 4. Can't be negative 2. Can't be 2. Can't be 3. But because we divided, and this was originally in the denominator, we also have to check these as well. So you have to, can't be 4. Oh, we already have 4, so we don't have to repeat it. And it can't be negative 3. We do not have that restriction. So a whole infinity of numbers, and 5 numbers can't be used. Okay? Cancel, cancel. These x plus 2's cancel to me. The x minus 4's cancel. The x minus 2's cancel. So you're actually left with x plus 3 over x minus 3, as long as x is not any of those 5 numbers. Number 5, n squared plus 2n minus 24 over n minus 4. This is pretty straightforward. No multiplying or dividing. So, what multiplies to negative 24 and adds to 2? Well, that would be n plus 6 and n minus 4 over n minus 4. What can n not be? You only have to check the denominator. N can't be 4. And go ahead and cancel. So you're just left with n plus 6 as long as n is not 4. Pretty straightforward. Number 6, for the function y equals x plus 3 times x minus 5 over x times x minus 9 times x plus 3, state all restrictions on x. Okay. You're just looking at the denominator. What can x not be? This one tells you x can't be 0. This one tells you x can't be 9, because if it were, it would cause the denominator to be 0. And this one says x can't be negative 3. So those are your restrictions. Number 7 says list the points of discontinuity. It's kind of the same as listing your restrictions, only instead of not equals, you're going to put equals, okay? And then we're going to tell whether they're asymptotes or wholes. So let's list them separately. What can x not be here? Well, there'd be a problem, a point of discontinuity, or as you guys call them, pods, at x equals 3. There's also one at x equals negative 2. Now, we just have to figure out removable or non-removable. The key thing to remember here, wholes are if they cancel out. Remember, you're taking something out of the problem, so it leaves a hole. The vertical asymptotes appear if they do not cancel out. Okay. So, x equals 3. Well, does that one cancel out? You betcha, it sure does. So that means there's a hole at x equals 3. Does the negative 2 cancel, though? Nope, it does not cancel. So this is a vertical asymptote, or VA as some of you have abbreviated them, at x equals negative 2. So there's your answers for that.